Hi and welcome back to part 3 as we continue. Here I'm just putting some oil on the ways and then I put the saddle onto the lathe. I found this the easiest way to reassemble the apron because now the saddle's sort of held in place. You've only got one moving part, so to speak. And here I just offer the apron up to the saddle. Get the bolt holes lined up. And then it's just a simple case of putting the two cap screws back in. Now that these bolts are nice and tight, it's time to move on and reinstall the clutch knob. This just screws on conventionally, but the screw that goes in the end is the opposite thread. So worth bearing in mind if you're going to strip one of these down, that you've got to do it up to undo it. Now time to reinstall the hand wheel. Just a simple slide on the shaft and then a grub screw to do down onto a little flat. And nice smooth action to the bed, which is nice, whereas before it was quite sort of draggy and grindy. Now it's just lovely. Fitting another control lever to the compound, just using a temporary screw here. This will be one of the first components that I need to make on the lathe when it's up and running. And gain nice action to the compound. Now sliding the saddle and the apron back onto the lathe over the lead screw. Now putting the carrier bracket back on the end so that the shaft is supported. These gears, I decided the way to tackle this was to grind away where the broken teeth were, and then I used masking tape on the side of the gears, which you'll see in a minute in the drill press, and I used a square so that I could get a vertical line for where the tooth used to be, as you can see here, and then I drilled 2 holes where each tooth should be and placed pins in them, which you can see here. It's not very clear, but there you can see them better there. And then I braze welded using bronze and filled in the gap so that the molten metal went around the 2 pins and in between the 2 previous teeth. And then it was a case of using a grinder to take away the bulk of the material, and then very laborious process of needle files and various different size files to get the teeth back. It took a long time, but it did work, and I'm overall pleased with the outcome. the lathe's back up and running, which it wouldn't have been had I not have done it, so it was well worth the effort. Here you'll see that there's a broken lug on the motor mount. Don't know how it happened, but this is how it come to me. So what I did was I got a piece of steel, welded it together to make a block that was deep enough. I then machined the top of that bed so that I had a flat surface, and then I cut a semicircle in it so that the tube or pole would fit through like you just see there, and then fixed it to the base with 2 screws. And there's very minimal play in it, and it's only really there to locate the plate and allow the plate to slide, so again, all things considered, that come out quite a good repair. Here rebuilding the head. And putting the main bearings back in. I didn't cover it in this video, but there are other YouTube videos out there of people tightening the nut that goes on the shaft to take out any play and backlash, which do a far better job of explaining than I probably could have done. So if you need to know, Google it, it's there on YouTube already for you. And that's the main shaft back in. Rebuilding the forward and reverse gear lever. Again, these pins, just a little bit of oil. All straightforward stuff really, it's the reverse of taking it apart. Luckily, the gears on the outside of the lathe, i.e. on the end of it, underneath the cabinet door so to speak, none of the teeth were damaged on those. It was only in the actual head that gears were damaged. So maybe these gears have been replaced at some point, if any of them did get broken. I don't know. But the only ones with damage were in the actual gearbox, or in the head should I say. Just doing these up loosely just to keep them all together, and then I'll put it on the lathe and start to mesh them to the individual gears that they need to run against. That little plate's got a little cutout in it which goes over a little sort of pin on the lathe itself, and then this gear set traps the plate against the lathe. And what I did was I meshed the gear from this gear here, and I just worked my way around until I got up onto the forward reverse gear set, and that way I was able to take the backlash out of each gear. And now the final mesh will be done on the actual clamp, which is there. The door hinge post, motor brackets or motor. Now rebuild the motor mount, new bearing in. This is a retaining plate that holds that bearing flat in the holder. And there you can see we've got the main shaft, the pulley and the end cap back on. This was quite tight, you have to look down and find the flat of the shaft and then get your fingers in there with an Allen key to do the grub screw up. But as you can see, it's running a lot smoother now and no noise. New motor bolts going in to fix the motor back to the plate, and then I can put the tower back on. You'll notice on the motor there's only one belt position, but on the bigger pulley above it it's actually a 2-speed pulley. I have ordered a 2-speed pulley to go on the motor, but at the time of finishing this video it hadn't turned up yet, so if there's any discrepancies there, that's why. But it now does have a proper 2-speed pulley on the motor as well. Reattaching the belt. This is installing the quick set. Now with this lathe you can see you've got the forward off and reverse tag on the front. It didn't have a switch there. When it come to me it just had a 13 amp cable with a 13 amp plug on it, and the cap had gone. So you used to have to just spin the motor over by hand. Obviously with all the work that's gone into this lathe I wanted it to work properly and I wanted it to look as good as original. So I found a forward reverse off switch on, I think it was eBay I got it from, and I made a bracket up to hold the switch in the original position, and then I went about rewiring the motor and all of the control gear so that it worked in a proper way. I also didn't want the lathe to have like a permanent neutral or permanent live when it was in the off position. I wanted the lathe to be completely isolated. So I made sure that when rewiring it that's how it was, because I didn't want any permanent lives or neutrals anywhere. If you're not sure when dealing with electrics, it goes without saying, you know, speak to or ask someone to help you, because it's not worth the hassle of getting something wrong and possibly injuring yourself or damaging equipment. But here I'm just showing you how I wired it. I got some 5-core SY cable, and that goes from the motor to the switch, and then I've got some standard 13 amp flex, which is the power in, and I also used a bit of that because I fitted a cap, which you'll see in a minute, and I've fitted that to the outside of the motor mount on the tower so that it's easily accessible, and we can change it if it needs to at a later date because it's sort of a serviceable part. And here you can see I've got all the ends on. This is the switch that I bought from eBay, which I'm now wiring up. You probably notice as we're videoing this, you can see the bracket that I made, which is just basically like an L shape, and then I rounded the top over so that I could pick up the original 2 screw holes on the front of the lathe to use the same location. Obviously with your electrical connections, standard thing, if you don't know, then it's worthwhile learning about electronics, but any electrical connection that you make, you always want to make sure that it's nice and tight and that it's not loose, because you can cause heat to build up through a loose connection, so to speak. So that first wire that I put on was the feed into the switch, and now this SY cable, which has got 5 cables in it, this is taking the switch commands from the switch, and it will run back to the motor windings, and then depending on the position of the switch will determine which way the motor goes, whether it be off, forward or reverse. And here you can see me feeding the switch back up into the body of the lathe, and then the shaft will actually come out of the centre of the original dial, and then I can use 2 Phillips screws to go in, machine screws, to the bracket that I made to use the original locating holes. And there we have it. Now, because I've got every intention of using this lathe regularly, I decided to put a digital readout on it, a DRO. You can see in the background there, that screen is the digital readout display. But I had to make these brackets so that I could fit the scales to the lathe. Here I drilled the apron and tapped a hole so that I could fit the digital readout scale on the back of the lathe. I wanted it to be nice and tidy and neat and out the way. So that was the mounting position. These 2 brackets here allow the reader to go lengthways along the actual lathe, and then the bracket on the back of the apron is what holds the reader so that it can slide it down the length of the lathe, and it worked out very well. Here just reinstalling the motor unit, and now pairing that 5 wire SY cable back. These are the wires from the switch, which will now connect to the motor. as you can see, if you remember, I said about modifying the motor cover on. I found a cast aluminium box that I had, so I picked up the 4 mounting holes of the top of the motor, and I've used machine screws down through the box into that, and then I cut the bottom of the box out, which allows me electrical access to the cables, as you can see. But once the lid goes on, this environment is now completely sealed from the outside, so no swarf or dust will be able to get into the electrical connections anymore. And as you can see, I've used a couple of glands as well, so that the cable are pulling against the box as opposed to the electrical connections. That lead that the gland that I'm doing up there, that is currently a fly lead that comes out of the motor connections, and that's going to have the cap on it, the starting cap. And it's these 2 wires that I'm holding here. Here you can see the 2 spring clips on the side of the tower, and that's what eventually the cap will squeeze into. When I bought the cap, it had 2 positions on each pole for spades, and obviously I've only got 2 spades going on, one on the negative, one on the live. So what I did was I insulated the other 2 to make sure that there was no chance of sort of fingers touching live connections or bits of swarf laying across it and electrifying the lathe, so to speak. Even though the lathe chassis is earthed, it'll save me having to reset the RCD. You can see them here. Just insulated them in some covering, and it's a simple case of squeezing it into the clips. Thanks for watching, and hopefully you'll catch up with us to watch the 4th and final part.